Hello everyone, I am Sneha, Assistant Professor, Department of ECE, Siddhartha Academy of Higher Education, deemed to be University. Now, I am going to discuss about implementation of algorithms using Raptor. So, in this slide, I am going to give introduction about the software Raptor. It is a freely distributed as a service to the computer science education community. It gives introduction by stating that Raptor is a freely distributed software. It was originally developed by and for the US Air Force Academy, Department of Computer Science. It is a flowchart based programming environment used for the students to visualize their algorithms and avoid syntactic baggage. Raptor programs are created visually and executed visually by tracing the execution through the flowchart, as you can see on the slide. So next is about from where we can get this website. You can sorry, from where you can get this software. As you can see on the slide, you can go to that website and can download directly. This is after downloading and installing. This is how the software looks once you open it. Next, this is the layout. As soon as you open a new file, you can see the start and end uh, options on the screen. And as you see that to run the after preparing the flowchart, for to get the output you have to run the program. As you can see that there you have to click on the play button, and pause is the 2 lines button, and stop is for stop button. So this slide focuses only on key components of the Raptor interface, the symbols which are used to build flowcharts, and the basic structure of a Raptor program. Basic structure means it includes only start and end options. And this is the structure. So program structure: when executing a Raptor program, you begin at the start symbol and follow the arrows to execute the program. A Raptor program stops executing when the end symbol is reached. A flowchart with start and end symbols is seen on the screen. This slide explains the fundamental control flow in Raptor. Program execution begins at the start symbol and proceeds along the arrows until it reaches the end symbol. So here, next comes the Raptor statements or symbols. The top four statement types: assignment, call, input and output. The bottom two types: selection and loops. So this slide categorizes the primary symbols used in Raptor flowcharts, grouping them into assignment, call, input or output, selection and loop statement. So as you can see on the screen, you find input output commands, assignment, call, selection and loops. So assignment, but that particular symbol is used for writing logic for any program. Input is for giving the input commands, and output is for displaying how you want to get the output to be displayed in the output. Selection and loop are used for condition statements. So here in Raptor, mainly we are going to use only input and output, assignment and selection and loop statements. Call is not that much frequently used in Raptor. And next comes Raptor variables. So here this slide introduces the concept of variables in Raptor and explains that variables are not initially defined. So in Raptor, variables are automatically created when they are first used in a statement. A flowchart showing a sequence of assignment statements you can see on the screen. So this slide visually represents the sequence of assignment operations that were explained in the previous slide. So as you can see on the screen, first is a start. Next comes as you have seen in the previous slide, assignment box is given in the square. So in that, I have already said in the previous slide that assignment operator is used for defining some basic logics of the program. So here in the second step, x is given the value of 32. Here you can see the x followed by backward arrow followed by 32, which means that 32 value is stored in the variable x. Okay, next comes x plus 1 is stored in x, which means that x is incremented by a value of 1, as x already has a value of 32. Incremented by a value of 1 means it goes to the 33. So now the x value becomes 33. The third step is x value becomes 33. Next, now x value currently is 33, and if you see the next assignment operation, x into 2, which means 33 into 2, total is 66. It is stored in the x. Now the x value is 66. Currently the first x value is 32, next x value is 33, and after that the third x value is 66. Backward arrow means that the value on the right side of the arrow is stored on the left side. In the left side means there is a variable x. So this slide introduces the concept of variables in Raptor and explains that variables are not initially defined. So as you can see on the screen, there is a flow chart explaining the different operations of different operations using assignment operator. In previous slide I have already explained that the assignment operator is used to define any specific particular logic of a program, and also along with that you can assign a particular value to a variable. So here the program will start with defaultly the program will start with a start option and end with an end option. Here in the second step you see that x followed by backward arrow followed by 32, which means that 32 value is stored in a variable x. 32 is stored in a variable x. Now so the next value is 32. In the third step you can see that x is incremented by a value of 1. So how do we define that in an assignment operator? So x plus 1 is stored in a x. So previous step x value is 32, so if we increment a value by 1, now the present x value is 33. In the last step, in the fourth step, x value is multiplied by 2. So the now present x value is 33. If we multiply by 2, now the total value will be 66. So now present x value is 66. In the first step x value is 32, in second step it is 33, and in now last step x value is 66. Now next comes common errors while using the variables. So if you see this, there here on the screen I have given 3 common errors while declaring the variables. So first one is, defaultly any Raptor program will start and end with a start and end. So I'm not going to explain again those two lines. So first one is y is stored in x. One important point to remember here is, in assignment operator any value can be stored in any variable. A value can be stored in a variable, but a variable cannot be stored in a variable directly. So here y is a variable and x is also a variable. So here it is giving variable y does not have a value. Okay, next one is 100 value is stored in a variable called miles. What is given in the next one? Mile is multiplied by 5 and that entire value is stored in distance. One common the common mistake is, in mile 100 is stored in a variable called miles, MILES. Here the second step is it is given only mile, so there is a spelling mistake, so it is showing variable mile doesn't have a value. Okay, next the third one is again 100 value is stored in a variable called miles. And what is in the next step? Distance to town is stored in miles. Distance to town is a string. It is not a numeric value, it is a string. Anything that you define in between double quotations will be taken as a string. We come to know about that string and creations, all those in the another separate presentation. So for now you can see that distance to town is given in a double quotations, which means it is considered as a string. So a string cannot be a numeric value, so it is not stored in a miles. Okay, so next slide is input statement or symbol. Till now we have seen few examples for assignment operator. Now we have to see input input symbol. See, if you observe, the shape of the input and output symbols will be same. The only difference is the arrow mark on which side it is given. For input symbol, arrow mark comes first, followed by a rhombus box. In output symbol, first rhombus box will come, then to the right side of the box you will get an arrow mark. That is the only common difference between input and output symbols. So here see the input symbol. If you double click on the box, then this dialog box will be coming on your screen. Here you have to give the input statements. Next one, procedure call statement or symbol. This is a call statement. A screenshot of the enter call dialog box is displayed on the screen. So this slide shows how to call a procedure in Raptor. Next one is examples. Example showing a call symbol. Next, a few examples taking into all the symbols into account: input, output, assignment, selection and loop. Output statement or symbol. So screenshots of output is shown on the screen. As I have said previously, if input and output symbols appears to be same, the only difference is the direction for arrow mark. For input symbol, first arrow mark will be on to the left side of the symbol, and in output arrow mark will be on the right side of the symbol. Same for entering the output commands, you have to click on the output box, then the following dialog boxes will appear on the screen, then you have to enter the output statements. Next, comments in Raptor. How to add a comment in Raptor? By right clicking on the specific box, you can add a comment. Generally, why do we use comments? To explain any particular line. Why are we using that line? So to get a in-depth knowledge of any particular line, we have to use comments. Next, sequential program control. So this slide introduces the concept of sequential program control, where statements are executed in the order they appear. Sequential means one by one. So the first statement is here. For example, I have taken 3 statements on the screen. So sequential means first statement 1 will be executed and the output will be displayed, next statement 2, next followed by statement 3. Next, selection control. So this slide visually represents a selection control structure which allows the program to choose between different execution paths based on a condition. So selection means yes or no. For any statement there will be two options, yes or no. If yes, what statement you have must be executed. If no, what statement must be executed. So if you see on the screen, selection symbol will be like, see on the right side, a diamond box followed by yes or no statements on either side of the box. So you have, before taking that selection box, you have to take some logic means logic must be taken in a assignment symbol. So see there, statement 1 is nothing but some assignment operation. Either some value is given to a variable or some logic is given. So if that is decision means, for example, I am taking statement 1 as x is equal to 10, for example. So decision means if x greater than 10, if it is yes, then statement 2a will be executed. If it is no, statement 2b will be executed. Yes or no, simply yes or no. If there is any condition with yes or no, we have to uh, blindly follow the selection control symbol. This is the example. Next, loop means there are different loops like if else while. For such cases we have to use loop. This slide visually represents a loop control structure which allows the program to repeat a block of code multiple times. Thank you.